Okay, folks, this is the part 2 of section 3.6 in your chapter 3 notes. We're in the middle of page 14. We just, at the end of the last video, we did example 3 together where they gave you a slope and a point, and we put it in the point-slope form and got that particular equation right there. Remember, they call it point-slope form because there is your slope, and the point that's on the line is the x of 1 and y of 1. Typically speaking, you do not plug in for x and y. So go ahead, you have the exact same kind of setup for this practice problem here. Pause the video and get yourself an equation through that point with a slope of -1/2. Right, let's see how you did. First we're going to start off with the formula. And we're using point-slope form because they give you a point and a slope, so there's your big hint to use that particular form of the line. We're going to plug in -1/2 for the slope, which is always m, so that's -1/2. So we don't plug in for x and y, we plug in for x of 1 and y of 1, and there's our information right there, x of 1 and y of 1. So we put the -5 in there. This negative here comes from the subtraction in the formula, and the y is 2. So we put that in there. You have to be careful when you're plugging stuff in. You notice that -5 is the x, so it comes first in the ordered pair, but it is the second thing that gets plugged in here. So this is it's not plugged in order because the y has to go first, even though up here the y comes second. And since this has a back-to-back negative like the previous one, we're going to go ahead and rewrite that because it's a little sloppy. Write that as 1 positive instead of back-to-back negatives, right? Now, if they said you put this in point-slope form, you'd have to rearrange it. You would distribute the -1/2 and add 2 to each side, and you'd have something that's in the form of slope-intercept form. But all it says is write the equation of a line. This qualifies as an equation of a line, and so there you go. There's your answer. All right, example 4 right below it, it says write the equation of a line that passes through these 2 points. So you ask yourself, well, what's the difference between example 4 and the last 2 problems? And the difference is now we have 2 points here, and then we're missing the slope. So you say, well, before, previously in the last problem we plugged in the slope and a point, so we need the slope. So if they give you 2 points, how do you figure out the slope? That would be using the slope formula, which we all remember from algebra 1 is y sub 2 minus y sub 1 all over x of 2 minus x of 1. And it doesn't matter which one you call it y sub 2 and y sub 1 as long as you're consistent. Remember these subscripts here, they call them subscripts because they're down below the variable, just like submarine is down below. These do not tell you to do a certain operation, like an exponent, which is called a superscript, that would tell you to square something or to cube something or something like that. This does not tell you to do an operation. All this is merely saying is we have 2 y's in the problem, so we can't just call it y. We have to give them separate names to keep them separate, so you call them y sub 1 and y sub 2. So this is basically saying this is the second y coordinate in the problem, this is the first y coordinate in the problem, and the same thing with the x's. Right? You're just trying to keep the variables separate. We're going to plug stuff in here. The y's are 11 and 7, and the x coordinates are 3 and 2. Now you could have just as easily said 7 minus 11 as long as your denominator said 2 minus 3. You have to be consistent. I chose to subtract in this direction here, so I had to subtract in that direction for both the top and the bottom of the fraction. When you do your math there, you get 4 over 1, which is 4. So we have a slope of 4 for this line. If you have trouble plugging numbers in the right spots, you can go up here and label the thing. You can call that the first x in the problem, the second x in the problem, the first y in the problem, and the second y in the problem. You can go up there and label those to help you plug them in the right spots. If you don't have a problem with that, don't worry about it. Now that we have our slope, we can treat it just like the previous example 3 and the practice problem that came right after it. We're going to start with the point-slope form of the line now that we have the slope and a point. We're going to plug in 4 for our slope because that's what we just figured out. And we're going to plug in an x to y for x of 1 and y of 1. It does not matter which point you plug in. So there's actually going to be 2 acceptable answers here. But what you have to do is you have to take them as a pair because these are called ordered pairs because they're paired together. If you want to use the 3, you have to use the 11. If you want to use the 7, you have to use the 2, so on and so forth, right? So let's say you want to pick the first one here. The 2 is the x, so we're going to put it in there. And the 7 is the y-coordinate, so we'll put it over there. So there you have an equation of a line that's going to pass through both of those points. The alternate answer, if you pick the second one because you like the looks of it, you'd plug in 11 for the y-coordinate, you'd still have the same slope of 4, and you plug in 3 for the x-coordinate, and it would look like that. You say, well, how could they represent the same thing? They both have the same slopes, and they're passing through 2 different points because the line is going to pass through a whole bunch of points as it progresses. And if you were to rearrange these in slope-intercept form, they would get you back to the exact same equation. All right, so you actually have either one of those answers would be acceptable for that problem. Flipping it over to page 15, there's a practice problem that's just like it, so go ahead and pause the video, write yourself an equation of a line is going to pass through those 2 points. All right, let's see how you did. You want to first figure out the slope. Start with your little slope formula. The two y's are negative 12 and 4, so I'm going to say negative 12 minus 4. And since I, again, subtracted in that direction, I'm going to do it again and say that for the x is 5 minus negative 3. You have to be careful with your negatives there. If you chose the other direction, it would have been 4 minus negative 12 in the numerator and negative 3 minus 5 in the denominator. Either way, though, you'd ultimately get the same slope. By doing the math across the top there, that gives you negative 16. Back-to-back negatives become a positive, so that gives you a positive 8 on the bottom, and when you divide it out, you have a slope of negative 2. Going back to our equation of a line, we'll start with point slope form. We're going to plug in negative 2 for the slope, and we're going to plug in something for x sub 1 or y sub 1. Again, you have a choice between one or the other, but you have to take them together as a pair. If you plugged in the first one, it would be minus a negative 3 when you plugged in x sub 1, and over here the 4 when you plug in y sub 1. We're going to have to rewrite that a little bit because you have back-to-back negatives, so we'll call that x plus 3. So there's your answer, and then your alternative answer, if you plugged in the other point, y minus negative 12 is equal to negative 2 is still your slope, x minus 5, and then you'd have to call this y plus 12 because we don't want the back-to-back negatives there in our final answer. So you could have this equation right here, or y plus 12 is equal to negative 2 times parentheses x minus 5, both representing the same line, and a line is guaranteed to pass through that point and that point. Right, our final idea of section 3.6 deals with horizontal and vertical lines. They have very simple equations. The equation of horizontal and vertical lines are missing one of the two variables. If it's missing x, it's going to be one kind of line. If it's missing y, it's another kind of a line. So when you're talking about horizontal lines, they're all y equals some number. So y equals 0, y equals 11, y equals negative 1/2. All those represent some kind of horizontal line. And the exact flip idea for vertical lines, it would be x is equal to negative 5, x is equal to 0.34, x is equal to 100. Those will all be examples of vertical lines, and we'll explain why that makes sense here in a minute. So example 5 says, go ahead and graph the lines on the coordinate plane. We give us one coordinate plane, we can put them both on the same graph, no big deal. X is equal to 3. Well, if you look up here in our examples, you can tell right there that that's going to be some kind of vertical line. You say where it's going to be located. Well, it's going to be located where x is 3. So you say, where's x3? Well, this is the x-axis here. You go over 3, and it's right at this spot, and we just said it's a vertical line, so you're talking about a line that travels like that. Why do they have the equations like that? When you see x equals 3, you're basically saying that no matter that the y doesn't matter, x is always 3 on that line. When you think about it here over in this line, as you're moving up and down the line, the y's always change. They get bigger as you go up, they get lower as you go down, but everywhere on this line the x-coordinate is always 3. This is 3, 0, 3, 2, 3, -1, so the x is always 3, so that's exactly what that equation is saying. Y doesn't matter, x is always 3. Very similar kind of explanation for y equals -2. Since it's y equals the number, you look here at our examples, and there must be some kind of horizontal line. And where is it going to be? It's going to be right where y is -2. So on the y-axis this time, it's at -2, down 2 notches. And so when it's going to pass through that point, and since it's going to be horizontal, it's going to be perfectly straight across the graph, right? Just like the explanation for the other one, y is always -2. So as you're moving left and right on this line, the x's keep getting bigger to the right, keep getting smaller as you move to the left, but y is always -2. No matter what's going on, y is always -2 on that line, which is why you have that equation of y equals -2. Right? That wraps up section 3.6, and you can tell that we're doing slopes of parallel and perpendicular lines here to finish off chapter 3 in a little bit. See you later.